Good afternoon. I'm Karen Kill. I'm the administrator with Browns Creek Watershed District, and we are going to talk a little bit today about two of the ponds, large ponds in the city of Stillwater. Both are not officially named, but we are referring to them as Brewer's Pond and Sinnet's Pond, although that's something I'm curious to hear what others are actually calling these locally. Maybe we can just quickly start with introductions. We are going to be recording this today to be able to post this online as well. So those residents or others who are interested.
How can I switch it to, right now it's just on my, I have to hold it up to my ear. How can I put it on a speaker?
On your iPhone, can you just hit speaker on your iPhone? On your, let's see. Well, I don't know if I'm able to see it that way. Just in your regular screen of your iPhone, is there a speaker option? Are you able to see us on your screen as well through Zoom?
Oh, what happened there?
I think there's a way in your audio settings maybe to connect it. I think we'll start with just introductions really quick. So again, I'm Karen Kill. I'm the administrator with Browns Creek Watershed District. Pat, do you want to go next? You'll be on the agenda here first.
Sure. I'm Pat Conrad. I'm with Emmons and All of Your Resources. We're a firm that provides technical support, engineering services to the Browns Creek Watershed District. And I've been involved in the past doing lake management plans for the Watershed District.
Thank you. Brett, do you want to go next?
Hi, I'm Brett Stubblestead. I'm a landscape restoration technician with the Washington Conservation District, and we work with the Watershed District to help administer their stewardship grants program. And part of that involves meeting with residents of the county. We offer free site visits every year to talk about ways you can improve habitat and water quality on your property.
Thank you. Becca, do you want to go next?
Hi, I'm Becca Oldenburg. I'm a senior water resource specialist, also at the Washington Conservation District, just like Brett, and working in water monitoring, partnering with Browns Creek Watershed District to collect data on a wide variety of their water bodies, including the two that we're talking about today.
And Ryan.
Ryan Fleming, a water resource engineer with Emmons and Olivia Resources, and work with Browns Creek on understanding flood risks, as well as a number of other different types of watershed planning efforts.
And Councilmember Polina, you want to introduce yourself?
Can you hear me?
Can, yes, just fine.
Okay, I'm Mike Polina. I actually live on city councilman from this area for, I think, 19 years. And I live on Brewer's Pond.
Excellent. And then we have the caller on your iPhone. It doesn't come up as your name. Do you want to introduce yourself? If you can figure out how to unmute, or maybe you can even write it in the chat if you can do it better that way. That's all right. If you're able to later, feel free to do so to identify yourself. Thank you very much for joining us. And as I mentioned, we will record this presentation today. I think we'll cut some of the beginning parts out here, but we'll record this presentation today in order to have this on our website so others can do this as well with us. So as we mentioned, we're going to be getting started here with just some basics of 101, sort of how ponds work, and talking about some things that people can do, residents can do on their own properties to improve water quality, and then talking about some flood risk assessments that we have been doing later, and having an opportunity for some questions and your input on your observations of these water bodies as well. So with that, Pat, I'm going to turn that over to you, and I will stop sharing so you have the ability to do so.
Thanks, Karen. Let me share my screen here. And if someone would do me the courtesy of letting me know when and if you can see my display there.
I can indeed. Thank you very
Excellent.
much.
And I'm in presentation mode and all. Okay, great. Okay, so as Karen mentioned, I'm going to lead you guys through just kind of a general overview of lake management, large pond management, kind of dynamics. Okay, you know, we are the ponds we're going to be talking about today are really large ponds. You know, they're not necessarily lakes, but in many ways it doesn't matter, right? I mean, we call them ponds, but people live on them. There's recreation on them. They're kind of the expectation that that you can use them as you do lakes, right? So the Watershed District, you know, has several very large lakes, and over the years, starting with Long Lake in the early 2000s, the Watershed District has gone through and systematically done lake management plans for each of their resources. Kind of starting with the ones that, you know, there's a lot of people living on them. There are a lot of recreational uses, issues. There's maybe impairments of, you know, large algal blooms, those types of things. And like I said, they've systematically knocked off all of the bigger water bodies, the bigger lakes in the Watershed District. You know, Masterman, the school section lakes, you know, Goggins, all of those lakes, Bass Lake, Benz. I'm sure I'm missing a couple of them, but you know, at this point, what the district is looking at is knocking off this whole slate of large ponds and doing kind of a wholesale management plan on these ponds, and that's what we're here to talk about today. We're going to talk about the last two there, Sinnets, and really what our project entailed is going through and doing a condition assessment of these water bodies, looking at their past water quality, what kind of aquatic vegetation or algae issues do they have. We did a really quick shoreline analysis to look for, you know, areas where we might have incompatible land uses going down to the edge of the pond that might, you know, might lead to water quality issues. We did some bathymetry work, and then finally we did some flood risk assessment that Ryan will be talking about. So the next step in the process is today, right? I mean, we're going to meet with you guys and kind of share our findings with you, discuss what maybe other issues you see on these water bodies, talk about what kind of things we can be doing as residents to improve the character of these water bodies, and maybe really just kind of set the expectation for what these water bodies are going to be into the future. You know, I mean, obviously these are not northern Minnesota boundary waters lakes, right? I mean, they are what they are, and kind of understanding that the limitations these shallow urban lakes have is part of this process too. And finally, we've developed a story map website for, you know, future use of residents, kind of a clearinghouse, if you will, of all the data that I'm showing today, kept live. Okay, so we've got water level information, we've got water quality information, and that'll all be kept live on this story map website for, you know, future use. So that's kind of the introduction. So, you know, really what I wanted to start with, and we always start with when we're talking about lakes and rivers and watershed management in general, is we always talk about that interrelationship between the watershed and the downstream resources. Okay, and so really the characteristics of that watershed really do play a key factor in determining the quality of that downstream resource. So you can see in the cartoon watershed that I have, you can imagine that the amount and character of the water running off of each of these different land uses is very, very different, right? You would expect a lot more water running off of our urban surfaces, our paved surfaces, than you would off of a, you know, agricultural land or a forest. You know, you can imagine that there's different pollutants and contaminants within that runoff water as well. So that's a really key component when whenever we're talking about water resources is what is that kind of that character of the watershed. It's particularly important in the case of lakes because in large ponds, and I'll use lakes probably more than I do large ponds in this presentation because that's, you know, what we're used to talking about. But in the case of these basins, you know, you really can think of them as a bathtub, whereas everything that washes off that watershed surface comes down, is deposited into that lake. Some of it, you know, flushes out that water rinses out in outlets, but in many cases, some of these basins are landlocked. A lot of the contaminants and pollutants settle out into the bottom sediments, and then they're allowed to kind of be resuspended or reused. So really anything that comes down into that basin for a large extent is available for future use. And that's important in the case of lakes and large ponds. And that what we're talking about really is nutrients, right? Fertilizer. We're talking about phosphorus, nitrogen, sediment, that stuff getting down into the bottom of the lake and then being available for biological uptake into the future. So it's not just that we're having watershed runoff getting into the lake. We have also got that nutrient pool in the lake of also available to grow things. So it's to grow, plants and algae. So what we're talking about here today is termed limnology, and that's, you know, a fancy word for lake science. And, you know, really it's covering all the components of a lake, from the biological, the physical, and the chemical. All of those sciences, if you will, are kind of lumped in as limnology. Today, I think what the important message is in today's presentation, and to take away from this graphic, is that both of the lakes we're talking about today are very, very shallow. And so you can see in this diagram what's referred to as the littoral zone. These water bodies are 100% littoral. Okay, so what that means is that there are no zones, there are no limnetic zones like on the right-hand side where there's no biological growth. Essentially in lakes, that biological growth zone is established by the sunlight's ability to hit the bottom surfaces, okay? And so generally what that means is about 15 feet of depth is when you no longer can get light penetrating to the bottom of the lake to allow for plant growth. It's different when we've got maybe we've got silty lakes, or we've got stained water, but a rule of thumb is about 15 feet. And so both of the lakes we're talking about today are well under that 15-foot maximum depth, so we've got biological activity going throughout the entire basin. So a couple components that we want to talk about are algae and weeds, macrophytes. Phytoplankton is algae, macrophytes, weeds. Algae within a lake, in and of itself, it's not a bad thing. But when we have too much of it, it's obviously a very bad thing. Nobody wants to swim in an algae-laden water body. You can have smell issues. There are certain algae in really extreme conditions where they have some toxicity issues that might be harmful to, even if you're ingesting it, dogs might have issues with it. But as I mentioned, it is a part of the ecological system. They are a food source for zooplankton. Essentially they are part of the food web within a lake or a large pond. But again, this is when we get concerned, is when we have severe algal blooms and too much algae. And that's what comes with having too much nutrients getting down into a water body. So also within lakes, we have like macrophytes or weeds. And again, small amounts or appropriate amounts are generally considered a very good thing. Residents may have issues with recreation if we get extensive mats of floating weeds. You might have issues with canoeing or kayaking or paddling through that water. But in general, macrophytes are a very good thing within a pond, and really what we're talking about is the kind of that interrelationship between these two. Typically small shallow basins like the two we're talking about today, they really can only live in one state or the other. They can either live in a clear aquatic plant dominated state, or they're in a turbid algae dominated state. And it's really dramatic, the ability of a lake to or water body to just kind of flip into that other condition. And what we see too often in our metro water bodies are water bodies that are in this turbid algae dominated state. And I think, you know, if you've been around small ponds, small lakes enough, you can kind of picture that, right? I mean, you can kind of picture that there's some of these water bodies where the water seems very clear and you've got a lot of plants, and then others you look out there and all you see is green or brown, and you've got no sense of kind of a vibrant plant community in those water bodies. So that's kind of what we're going to be talking about today. And then for the next slides, I'm just going to run you through kind of what our findings are in terms of the assessment work that we did on each of the ponds. And I'll start with the Sinnet's pond, and then we'll finish up with Brewer's. So Sinnet's is also referred to as the Jackson Wildlife Management Area pond. It's about 14.3 acres. There's no ordinary high water mark level data that I could find in the system. And I will mention that the data that I'm going to be presenting to you, we have pulled from state websites, state clearinghouses, but in actuality, that is Watershed District data. The Watershed District collects monitoring data, water quality data, lake level data. They submit it into a state database. That state database then kind of serves it up, if you will, on their websites. And so then that's kind of what we're showing you today. And what the story map system that I described for you will be a better way for district residents to kind of access all these different areas that Watershed District has collected this data. They'll be able to access that in one spot. So what I'm showing here is the lake shed to Sinnet's Lake. And generally with lakes and large ponds, you know, that smaller that ratio of watershed to lake to basin, the better. You know, it's less area, less water getting down to the bed, you know, less potential for contaminated water getting down to the water body. You know, in the case of Sinnet's, I should mention too that, you know, what we're not showing is that, you know, Long Lake drains down in through Jackson Wildlife Management Area pond. And so that does have an influence in the quality and the character of that lake. In terms of land uses within the direct watershed to the lake, you know, we've got some urbanization, we've got some impervious areas with the roads and the houses in that area. So these are, you know, these are potential contaminant sources to that lake. So these would be areas that we would want to look at. You know, if there were any ways to clean up the water that runs off of these surfaces before getting into the pond, those are the types of projects that we would want to look at, and that's the stuff that Brett will be talking about in a minute here. In terms of a lake grade, the 2021 data, which was the most recent we had access to when we were working on this, I think 2022 is available now, but the water quality is not that bad in this lake. We've got it as a B+ grade. I'll note that the lake did not stratify in 2021. Essentially what that means is that, you know, due to it, deep lakes stratify in terms of there's a warm zone on the top and a cold zone on the bottom. Again, due to that light penetration down into the water body. And so you have two very separate, unique columns of water, and that doesn't happen in these shallow lakes. In terms of bathymetry, we conducted this work last summer. Becca did this stuff. She can answer any questions you may have. And so a deep hole of about 7 feet was found on that kind of that western lobe of the pond. In terms of overall water quality, this water body is trending fairly good, right? It's more on that mesotrophic edge of this scale. You know, the kind of the take home of this slide is, you know, where you end on this scale in terms of the transparency and your phosphorus concentration. You can just kind of look at blue being good and green being bad, right? And so we get kind of concerned when water bodies get up and over that 60, but you can see this water body is kind of trending around that 58 as an average for the scores for this trophic state index. Moving on to water quality. This is essentially a measurement of how deep into the water column can you see within this water body. And so you can see we've got values from 2010 through it's maybe 2019 in this graph. You can see how it varies throughout the year, and then kind of that average through that band. Really, the trend line, you know, maybe not that great. Maybe hit a low in 2015, and maybe is getting better. The clarity that we're seeing on here is on the order of 4 to 6 feet. Finally, in terms of data that the watershed collects, water level, we've got water level going back many years on this. It's been recorded since the late 90s. So you can see kind of how it has varied over time. You don't get a huge level of variation because of the outlet structure, and it is kind of a flowing system through this one. Some of the other ponds that are landlocked is where we wind up with really vast differences between the lows and the highs on this. Ryan will be touching on this a little bit more in his presentation, so I'll go ahead and jump on to the next slide. Another one of the assessments that Becca did this last summer is a shoreline survey, kind of a rating of that shoreline in terms of how natural it is versus how much shoreline do we have in kind of artificial surfaces, or maybe mowed lawns, or you know, maybe potential for erosion. And so you can see, you know, the majority of this shoreline is in good shape. There might be a couple areas here and there that could use some TLC and maybe some of the practices that Brett's going to talk about in a minute here. And when we're talking about, you know, natural lake shoreline, you know, when it's rated good, you know, this is kind of what you should think of, right? There's really a very gradual transition from the upland to the water. We've got, you know, kind of a clear covering of plants going through that zone. You know, obviously it's kind of twofold. We're providing habitat for fish and aquatic amphibians and all kinds of animals that use that edge. But then we're also protecting that edge from an erosion standpoint. So when water is kind of flowing down over this zone and into the lake, it's got a good vegetative cover, so we're not getting erosion off of that and contaminations and pollutants into the water body from the shoreline. So that's when we're talking what we think of as a good natural shoreline condition, as opposed to when you'd have a mowed edge up to that and maybe, you know, drop off with some rocks and that kind of thing, where it's not, you know, super stable and it's not good habitat within the water body itself. In terms of the aquatic macrophyte, the aquatic macrophytes that have been found in the lake, there's a pretty good diversity of macrophytes in this pond in terms of what you would expect to see in this area. There is some there are some invasive species, though. There's Eurasian water milfoil throughout this pond, but then a handful of native species as well. And it's likely that milfoil has come down from Long Lake to kind of populate this pond. In terms of the fisheries survey, this is one of the few large ponds in the Watershed District that does have fisheries data. It was collected back in 2013, and you can see kind of the generally what species we had. The majority of the fish that were sampled were bullheads. You can see there were a few bluegills, some sunfish, and pumpkin seeds. And you can kind of, you know, it's likely, again, it's likely due to that contribution from Long Lake that these fish were in this pond. Okay, so with that, I'm going to go through and present the same information that we just saw for Brewer's Pond. Again, you can see we've got the lake shed here in terms of area draining into Brewer's Pond, a very small watershed to lake basin ratio, which is nice. Lake size around 9 acres, an ordinary high water level 891. Again, some of this lake level stuff I'll leave for Ryan to talk about in his presentation. Again, when it comes to the quality of the watershed for Brewer's Pond, very similar to the last pond where we do have some development in this area. And, with that development, we've got those impervious surfaces. We've got, which are typically a little dirtier than maybe a forest area or a wetland area. So these would be the areas that we would want to address with any kind of BMP that Brett will be talking about. In terms of water quality, the 2021 monitoring report put this one at a D+. So, I think this one, again, it's a shallow lake, didn't stratify as much as the previous lake, but this one we might be in more of that turbid water, algae dominated system. Bathymetry, actually a little deeper than Sinnet's. We found a deep hole of 11 feet, a lot of area in that 10-foot zone. For Brewer's Pond, we actually have a little less data available for Brewer's Pond than with some of the other ponds. It's been added to the district's monitoring program a little bit more recently than some of these other water bodies. But here you can see how we're tracking with total phosphorus on the left and Secchi transparency on the right. And you can see for illustration purposes, that red line running through both of these charts being kind of that level of concern. So on the left-hand side with that, with the phosphorus, these kind of read opposite. You want to be below the line on the total phosphorus, and you want to be above the line on the. No, did I say that right? Yeah, so I did. So you can generally see these are the transparencies on the right-hand side. The transparency, you want to be below a foot, and in most cases we're above a foot. We're less than a foot of transparency into that, or these are meters of transparency down into that water body. So again, this one seems to be more of that turbid state where you really can't see very deep down into that pond. You've got some pretty murky water in this water body. In terms of lake level, we also have a little bit less data available for this pond. Again, Ryan will get into this in more detail, but we did see that high spike like that we saw in a lot of district water bodies around 2020, and then kind of a decline since that point. In terms of the shoreline rating, this lake, we've got maybe about half of it is in kind of that natural condition, and maybe a few more of those moderate to heavily developed shorelines on this water body. Again, these would be potentially areas where you might want to look at in terms of potential to do future BMPs. And you can almost see that in the aerial photography that corresponds to those lake shores where you might have a little bit more algae growth outside of those areas than you do in any of the other areas. So in terms of aquatic macrophytes, the plant community is dominated by native aquatics. There's very limited growth beyond the direct shoreline, but no invasives were found. So again, kind of the story with Brewers is that it's in that more turbid water state. Nutrient reduction strategies might get it to flip. There may be things that we can do in terms of management practices within the water body, within the watershed to try to get that to flip. But right now it's kind of firmly within that turbid water state. So with that, I will open up to any questions. Otherwise, we can turn it over to Brett to talk about, what can we do as residents to impact and affect water quality.
Great. All right, give me a second to share my screen. All right, everyone's seen that shoreline cross-section slide there.
Yep.
Great. Well, hello, everyone. I'm just going to take a few minutes to piggyback off of Pat's presentation to introduce some of the practices that you can incorporate into your landscape to help protect water quality and enhance habitat for wildlife. Starting with shoreline buffers. Let's see. Is it going to transition here? There we go. So taking a look at a few past slides, it's great to see that there's a lot of intact, high quality shoreline, both on Brewers and Sinnets. But if you do find opportunities to restore or enhance an existing native shoreline buffer, there are really great practice with nested and overlapping benefits, both in terms of water quality improvement and habitat enhancement. So they help prevent shoreline and reduce shoreline erosion with these fine rooted, fine textured emergent or aquatic plants or grasses and sedges that occupy the shoreline zone, help hold the soil together, stabilize the shoreline, and filter out pollutants like excess nutrients from upland sources. I'm not sure if you're seeing my cursor, but I might be pointing to things here in the slide. And they also, they're great for incorporating wildlife and pollinator habitat. You can see this meadow blazing star with a monarch on it there. And they're a really great way to incorporate diverse pollen and nectar resources to help support some of those wildlife that are becoming, and pollinators that are becoming increasingly threatened. So there could be some great opportunities out there for some of you. And I'll just reiterate again that we help administer the Watershed District's Stewardship Grant Program, and we offer free site visits. So we're happy to come out and think through and brainstorm some ideas with you. Along with that, preserving down trees, snags, or other forms of what we affectionately call woody debris, coarse woody debris on your shoreline can be another great way to help support wildlife habitat for aquatic insects, fish, turtles, ducks, other migrating waterfowl really rely on these small little micro habitats for reproduction and all kinds of things. So it's not necessarily something that you need to clean up or drag away. So in a lot of cases, they're really great features to keep in place. Bioretention or rain gardens and swales, concept or a practice that a lot of people are familiar with now, but essentially, they're planted basins that are designed to collect and treat stormwater runoff from small impervious surfaces like driveways or roofs, often designed with engineered replacement media or soil to help enhance and facilitate infiltration. But another really great way to improve aesthetics around the home, incorporate more pollinator and wildlife habitat through diverse and well-designed native plantings. And just a really diverse, functional, and multifaceted practices that you can think about that can fit into a variety of contexts. So, and they're really fun to design. So we're happy to work with you on that. If you're looking at some other areas to improve pollinator habitat or just improve water quality more broadly, and you have an intact or a shoreline buffer that's in really good condition, and you're looking at other areas around the landscape where you can help facilitate some of those benefits and functions, the lawn is a really good place to focus on. And it's, we don't often think about our lawn maintenance practices, but there are quite a few things that you can do in terms of how you're approaching turf maintenance to help filter out sediments and pollutants, reduce fertilizer input by encouraging healthy, robust turf and foliage and root systems. And by also potentially incorporating flowers and forbs into your lawn as well to help support pollinators. Some of the more common species that we see being seeded and interplanted into these bee lawns include Dutch white clover, self-heal, creeping thyme, ground plum. We actually have a bee lawn at our office that has been doing great over the past few years. It's often just covered with bees and butterflies throughout the year, and it also performs from a water quality perspective as well. So another good thing, another good area to focus on around the landscape. And for areas where there's a little less space available, there's maybe not room for a rain garden or a swale or another form of infiltration practice. Dry wells or French drains or rock infiltration is another good strategy for reducing runoff volume and collecting and capturing stormwater from small impervious surfaces around the home, say next to a driveway or a garage. And just keep in mind that when you're doing work around the shoreline zone, you're thinking about pursuing a project in the next year or so, there are a handful of projects or practices that are regulated by DNR and Watershed District permit. And so some of those are listed here and linked in this slide. But we're happy to, if you're wondering what you are or are not allowed to do on your shoreline, we'd be happy to answer some of those questions and help you work through the permitting process through the Watershed District or the DNR. And Karen's a great resource as well. The Watershed District is a great resource, but you're welcome to reach out to us as well. And this is a link to our site visit sign up form. With my contact information there below. But this, you click on that link and it'll pull up a Google form that you'll fill out that makes its way into our database system. And we will then reach out to you to hopefully schedule a site visit coming up this spring or summer. So don't be afraid to click on that link and sign up for a site visit or reach out directly. Be happy to meet with you.
Thank you very much. Ryan, do you want to lead us from there into the flood risk assessment?
Yep, I'm just getting my screen share ready here.
Excellent.
Are you able to see my presentation? All right. So I'll be talking about flood risk assessment, and this is a piece of these lake management plans that we added recently. Normally we focused on the things that Brett and Pat talked about, but with rising water levels lately, we've started to take a little closer and critical look at flood risks. And I like to begin these presentations by briefly explaining what we're talking about with the 100-year event. A lot of people hear that term and it is a little bit misleading. Statistically, it's a storm depth that, based on the historical record, has a 1% chance of occurring in any given year. And that's to say it can happen more than once in 100 years. In fact, statistically, there's a 1 in 4 chance of it happening during a 30-year mortgage. And often people are concerned with flooding having to do with their homes and their mortgage. In our area, the storm depth is 7.2 inches of rainfall happening in 24 hours. That's applicable to most ponds, wetlands, and lakes, and including these two that we're looking at today, Sinnets and Brewers. Some areas of the district are landlocked where they don't have a natural outlet, And we look at a little more extreme event where we consider everything's frozen, so the soil doesn't have the ability to uptake any of that rainfall. And we look at that same 7.2 inches happening on frozen ground. What brought this study on was the unprecedented precipitation we experienced in 2019, 2020. And you can see on the image here a couple examples with the blue box highlighting water levels reaching their historical peaks. For instance, in July Avenue reached a historical peak in 2019, as did Brewer's Pond, and Pat Lake reached nearly a historical peak. As Pat Conrad had shown for Sinnet's Pond, it has a large capacity outlet structure, so we didn't really necessarily see that great peak on the in the water level record for that particular pond. Another thing that's somewhat recently changed, at least in the past 10 years, is that 7.2 inch 100-year rainfall event that I mentioned. Actually, prior to 2014, we were thinking that the 100-year event was 5.9 inches. That's something that's put out by NOAA and studies that they do. And when we were thinking it was 5.9 inches, that was based on studies of rainfall and precipitation through, I believe, the 1950s or 60s. Now in 2014, they took all of the precipitation records up until about 2011. So we added quite a bit to our rainfall record to look at statistics on that. And that's where we come out with that 7.2 inches of rainfall happening in 24 hours. So with the rising water levels and the revised 100-year rainfall, we're able to take that and run it through some computer models to predict high water levels. Here's a brief history on the difference in the studies that have been available and what we've done with this study. Shown here is FEMA's 100-year floodplain for, this is Bass Lake. I have these images for a different lake, but this is their 100-year floodplain for Bass Lake, shown in the cyan with dots. And that information they collected was based on analysis done in 2004, though the maps didn't become effective in until 2010. So that 2004 analysis was looking at precipitation records we had up until then, but also topography and water level information that we had at that time. And this is the map that determines whether or not you are required to purchase flood insurance. If you are inside of that blue area, you are required to purchase flood insurance if you have a federally backed mortgage. And if you're outside, you are not required to have that. Now, today we have much more accurate elevation data. In fact, it's accurate to within about a foot. That was all flown about 10 years ago. It was sponsored by the Minnesota DNR. And what we're able to incorporate into our computer models is looking at what areas do we have more depressions in the landscape that would collect and trap water. And those are the magenta areas shown here around Bass Lake. And what that brings to light is two things. One, Bass Lake may not be receiving all the water that we thought it was with the FEMA study, but also it's showing us where there may be some additional flood risks to structures, roads, driveways, etc. Also, what we looked at in this study was particular properties and the amount of flooding on those properties. This helped us zero in on properties that we might want to seek additional information. And those are the red lines on the map. Now you see I brought in some yellow. That is the roads, driveways, as well as the buildings are green in this. So we're able to see where some of those intersect flood footprints. And then last but not least, we did pull in the county's database on septic locations and well information so that we can know where those might intersect the water levels. And mentioning the well and septic systems is important, not necessarily around these ponds, because the majority, if not all of the properties are on city water and sewer, but in other areas of the district, we do get concerned with inundation of drinking water wells because that can introduce pathogens and contaminants. And then septic systems can cause system backups into properties, into homes. as well as groundwater contamination. Getting into the findings of running the computer models and looking at those water levels, what can we anticipate these ponds to bounce up to and have their flood footprint? Shown here in orange is the flood footprint on Sinnet's Pond. This is an easy one because we did not find any roads, structures, septics, or wells that would be impacted by that 100-year footprint. However, we did see one property that's got a well. We did not identify any with septic, but there are some that we've flagged for following up with just to make sure that we've got all the information. Moving on to Brewer's Pond, here again shown in orange is the 100-year high water level footprint. And we didn't identify any roads or driveways that would become inundated for this event. But we did find one building that is within that footprint, and that's shown in bright orange with a yellow outline. And because it intersects the 100-year high water level, we consider that to be at a higher risk of flooding for that event. Another disclaimer on this, we're using state and county databases for these maps, and they don't capture every single secondary building, pole barn, nor do we have all of the well and septic information. In fact, there are 9 properties around Brewer's Pond, which maybe the county well index shows that there's a well on that property, but however, there's no septic on that property. So we are seeking some more information on that. And I'll zoom into that one home that's near Brewer's Pond that may be at risk of flooding here. You can see it outlined in the yellow. These are automatically generated by remote sensing. I think it takes into consideration a reflection off an impervious surface, and you can see that the outline isn't perfect around that building, but it does give us a general enough sense to be able to say, well, that looks like it could be at risk of flooding. The outline in the dotted orange outline is actually a 15-foot offset that we also flagged anything within 15 feet of the flood footprint, just because that gives us a little bit of buffer. We know that all of our data isn't perfect. Obviously, you can see from this yellow outline. So we want to make sure that we're aware of things that are in close proximity to what might be flooded. A couple notes on things that you can do. Based on the 100-year water increase, so from where the model simulates the water level starting, and again, that's that 2019, 2020 high water level, and where it actually bounces up to for that peak water elevation, that distance is about 2 to 4 vertical feet, depending on which pond we're looking at. 2 feet for Brewers, 4.5 for Sinnet's, and 4.5 is greatly impacted by Long Lake because that whole system connects. But considering the amount of bounce on those water bodies, and then looking at how long the model predicts that water would drain out of the system, it's on the order of several weeks. So if you're looking at your building or your well or your driveway, the greater vertical distance you've got from where that water level is at any given time, obviously the better. Desired for Brewer's Pond, I would recommend you'd want about 4 feet at any given time. And that's because if the 100-year event happens and it bounces up 2 feet, you've got 2 feet of buffer in vertical distance for some level of safety. And then because Sinnet's Pond connects with Long Lake and it's much more flashy because it's got a much larger watershed, that recommended distance from the water level at any given time is more like 7 feet. Now, as you saw in the graphics, we didn't have any concerns with buildings within that footprint of the water body. However, if the water level is greater than your comfort level in any given year, you could consider enacting a flood action plan for your property. And that might include identifying low areas, identifying areas that are prone to erosion that might erode away if it gets very wet and could threaten your infrastructure, your 3-season porches, retaining walls, building foundations, and then plan to protect those measures for those infrastructure and preventing water intrusion. couple other recommendations are to estimate the time that it might take to implement this. If you are worried, some of these actions might take a little bit longer if you need to hire a contractor versus a weekend kind of project for landscaping. And some of those flood mitigation strategies can be as simple as runoff and snow and ice management, making sure that your culverts and gutters are clear, as well as making ditches, if you've got roadside ditches, making sure those are clear and they can convey the water away. Landscaping that can direct water away from your foundation. You want to have positive drainage away from your foundation so you're not trapping water near there. Considering a secondary power source for your sump pump, if you've got one. We did have one resident along Long Lake that installed an exterior French drain with an additional sump pump just to make sure he'd get water away from his foundation in the event of a flood. Also, applying waterproof sealants or membranes to the foundation can help prevent that water intrusion. It's kind of a timing thing. You know, eventually that membrane may become overwhelmed by the water, but if we're talking about a short period of time and you have an extra layer of protection on your foundation, that may be the difference between water getting in and causing damage to your property or not. Also, sandbag barriers in the event of extreme flooding, and that's a temporary measure, but they do take some time to construct. And last but not least, purchasing flood insurance. The National Flood Insurance Program is available to all. It's a lot cheaper if you're not already in a floodplain. So if you're required to get it because you're in the floodplain, it can be quite costly, but it's cheaper if you're not in that floodplain. There are some things that we are working with local governments to do. We're regulating new and redevelopment to adhere to stormwater runoff standards, such as making sure that some volume is captured and retained on the landscape for some of the larger developments, as well as making sure that new buildings are allowing for that distance, that vertical distance separation from the water level. Also, we are keeping a close eye on water levels around the district. When we had those times of higher water in 2019 and 2020, we had representatives out looking at the water levels on a weekly basis, just so that we knew how it was trending, so that we could inform the public. We were also doing some localized groundwater measurements where we thought that that had an influence on some of the surface waters. And then knowledge sharing. We try to keep up on the current state of the science with respect to flood response planning. And then also we try to link residents with available guidance and information resources. These slides will be up on the website at some point following the presentation. So these are clickable links to various resources from the local flood preparation information at the Washington Conservation District. You can see the top link there. We also have a link to the Minnesota Lake Finder website. They update the water levels monthly there, so you can be aware of what the water level is. And then there are also some great mapping resources, like the DNR has this lake and flood elevations online. You can zoom in and look at your parcel on that and look at the water footprint if there is a FEMA high water level on that. And then the Association of State Floodplain Managers recently came out with a website called reducefloodrisk.org, I believe. It's a clickable link on here. And that has facts about flooding and mitigation ideas for everybody from the homeowner all the way up to the large high-rise manager.
Almost didn't unmute myself. Thank you very much. With that, any questions or comments or things you'd like to share or ask for the group from any of our folks who are here? We must have done a great job telling you everything you ever could have wanted to know. I see you unmuting yourself, Mike. Was there anything you wanted to add?
Well, I was just going to add some of the things on there we've done over the years. For those other people that don't know me, Karen, I used to run the parks for Washington County. So I've been working a lot with fisheries and things like that. A lot of those fish in Jackson, Brewer's Pond were put in there by the DNR. So that was all stocked by the DNR over the years. So we made it, they're considered fishing in the neighborhood programs. I remember that program they had. So that's how a lot of those fish got into the lake. About 25 years ago, that house on the south end of Brewer's Pond, water was actually right up to the doors of the house. It did not drain out of there, so the homeowner pumped about 4 feet of water out of Brewer's Pond. That might have been 30 years ago. So that was a long time ago. They've been used for rearing ponds, recreation. A lot of the neighborhood kids have used those ponds for. My kids grew up on those ponds fishing out there, and they loved it. And I think the water depth on Brewer's Pond, we found 15, 16 feet with our ice fishing depth finders out there years ago. So just so you know, I mean, it doesn't make much difference, but just so you know, there's a little more depth than you might think. Those are just a couple of things I just happened to notice in the presentation.
Thank you. Thanks for those comments. How long have you lived on Brewer's Pond, Mike?
I think since 1985. So, and the neighbors have done tried to do a lot of noxious vegetation control out here. We had the whole neighborhood out here work for 3 years cutting buckthorn behind our houses. It was really pretty bad. The other thing to think about is on the end of Northland, right by my neighbor's house there, that drainage pipe went down there. That was like you could lose dump trucks and everything else in the erosion there. So a lot of that dirt ended up in Brewer's Pond. And I don't think that pipe is still big enough to handle all the water that comes down that hill. And it erodes over the top, or it flows over the top of the culvert and then dumps down that hill there, and it starts eroding in there again.
And that pipe that you're talking about comes up from on the northeast side of Brewer's Pond?
Yeah, it's right next to my house, right in between my house and Tim Troyan's house.
Okay, yeah.
There's a pipe there, and you can see where it's dumped all the silt into the lake.
Well, maybe that's why we're not finding the big holes you used to find. Maybe we filled them in.
Yeah. The only thing that really concerns me, and I've talked to you about that, Karen. I can't believe how brown that pond gets. It's horrible. But the waterfall. I was president of Minnesota Waterfall Association, so I've got wood duck houses all around down here. The habitat for wood ducks is awesome down here. Every one of my houses is full of wood ducks, and it's really fun for all the neighbors. I've got all the neighbors doing it now, and they love it. So
That's cool.
but that pipe is a concern next to my house, and that's gone on for years.
Any other comments? We had one other for questions. We had one other resident here joining us today. So just want to give an opportunity for you to ask any questions here today, or feel free to follow up after the presentation.
Karen, are they going to do anything about the north end of Brewer's Pond is just loaded with reed canary grass? And that destroys habitat too, and that doesn't help much.
That would be a great opportunity to work with the landowners and, talk about some restoration opportunities. Reed canary grass is so prevalent in our landscape now that unless we really have a large effort, widespread effort, there's so much seed source to come back in that if we don't have someone who's kind of willing to do it, the Watershed District, doesn't have the resources for public funds to go after all the reed canary grass for sure. But there are definitely opportunities and some techniques that, if a resident really was interested in trying and tackling it, it's not a small effort, but that's, something I think Brett could meet with someone and give some guidance about some strategies to start that battle.
So we would have to work with Sean John, behind our house back here, the parkland.
Yeah, it's
The
a
neighborhood was interested in the low grass prairie out there and trying to get something decent out there instead of all the just junk.
well, that's something we would definitely be willing to talk with the city and meet out there, maybe even, sometime this spring or summer and talk about some strategies or what
Okay.
are some ways that we could at least diversify it to some extent,
Okay.
try to battle some of it. I have seen in some areas like along Long Lake where we've had more shade, where more trees have come into an area where some of the Canada blue joint has been able to actually outcompete the reed canary grass, which is the native grass. So, maybe there's some different strategies about looking at what some of the plant life and things are right in that area of the park, just to see if there's some ways we could battle it. But do you have any thoughts on that, Brett, off the cuff?
Yeah, it's when you're dealing with, a monotypic stand or a dense monoculture of reed canary grass, it's difficult to manage, but there are some techniques and species that you can, flowering species that you can potentially get established and incorporated into dense stands to hopefully at least improve some habitat, and it does become more manageable at a smaller scale. So I guess I'd be interested to meet with you this spring to take a look at the area that you're referencing and see what the options are, best options are.
Well, great. Thank you all for joining us today. And if you have any other questions or comments or things that you'd like for us to address, or again, if you're interested in a site visit, we'll be getting this information up onto our website under Brewers and Sinnet's Pond. But otherwise, you have my contact information from the letter that was sent out today. Feel free just to reach out and I can connect you to those resources as well.
That's great.
Thank you all very much. Have a great rest of your day.
Thank you.
Thank you.
Thank you. Bye, Don.